Hi, this is a dumbass, whoops, sorry, I meant his name is Bro. Bro has never experienced anything other than the eternal despair of darkness. Today is his lucky day as he will learn about gravity. Oops, I forgot to pay the electricity. As you can see, Bro is now falling at a rapid and gallant pace of 9.8 meters per second squared, which is the acceleration of the Earth's gravity. Oh. That was not supposed to happen. Okay, Bro is already back. That means we can talk about the range of a projectile. Let's say one day you're getting chased by the eldritch horrors beyond human comprehension and you want to kill it at a safe distance. Then you want to know at which angle to throw your useless ball at it to deal maximum damage. The answer is actually... Okay, well, Bro ruined it and the answer was 45 degrees, so that's that. Now you might wonder why Bro just got discombobulated by the humble vehicle known as the truck. Well, I'll have you know this video is actually about the Doppler effect and not gravity. You've all been fooled. To understand this concept, we must understand how we measure the sound frequency. In short, the more times a sound wave comes in contact with Bro in a second, the higher the frequency and therefore the higher the pitch. Now on to the first case, where we have a moving sound emitter and an immobile listener. We can see that on one side, we have Bro, who will have the source moving towards it, and the other, we have evil Bro and he has the source moving away from him. By comparing the two, we can see that the one on the left experiences a decrease in frequency while the original Bro experiences an increase in frequency. Take a listen. Now for the second scenario, Bro will be the one moving and the sound emitting JBL speaker will be the stationary one. As we can see, moving away from the object at high speeds decrease the frequency and pitch, and the opposite will happen once Bro moves back towards the speakers. Also notice how the frequency only changes whilst Bro is in movement and not when he's stationary. That is because if we take a look at the actual formula to calculate the frequency change, we notice that the only variable that affects the Doppler effect is the speed at which the two objects are moving. Now finally, in order to find out whether it should be a plus or a minus on the equation, we simply need to find the direction at which the speed of sound is going relative from the source to the observer. If they're going with the direction of the sound, the sign becomes negative. If they're going against the direction of the sound, it becomes positive. And of course in most cases, the two objects will not be going the same direction, but the same logic applies. Think of when you're on the beach and running into waves. You will feel a lot more waves if you run towards the ocean than if you were to run away from it. Now finally, looking back at the previous cases, we can also figure out why the pitches are higher or lower. In this case, where the observer is stationary, we can remove the speed of the observer and all we have left is the speed of the source. And since the denominator is bigger than the numerator, the new frequency is guaranteed to be smaller than the original one. That about covers everything you needed to know about this funny sound trick. Thanks for listening, and now it's time to banish Bro back to the forever emptiness.